Hello everyone, welcome to Physics Mage. Here we have a good problem which can test your understanding of collisions, conservation of momentum, Newton's laws of motion with friction, and use of proper frame of reference. If you haven't tried this problem, better pause this and try solving it once. If you fail at getting some answer, then let's see how to solve this problem. Here we have a board A is lying on top of board B. Together they form a single unit and move with some velocity V on a smooth horizontal surface. They collide with another identical board C. There is no friction between A and B boards, but there is friction between A and C board. So upon collision, boards B and C are firmly coupled and do not move relative to each other. The length of each board is L, and board A stops moving relative to board B and C at the moment. It is entirely located on top of board C. Find the displacement delta x of board A from the moment of collision until the relative motion of the board stops. If the value of delta x is alpha L by 21, the value of alpha is our question, and they are asking us to take pi value as 22 by 7, and all the boards are identical. So dear students, if you have already tried, you know that we have a velocity vector given and A and B are moving together and there is no friction between A and B. So because of inertia of motion, they just continue to do so. And there is another identical block of length L, and this was initially at rest. Okay. Now this A and B system, which is moving, it will undergo collision with C. As a consequence, then we have some momentum exchange. So we will start with an idea. At t equals 0, what happens? We'll see. At t equals 0, let's say that this board B comes in contact with board C such that these two will get attached. Okay, so if they get attached, then board A, which is on top of B, that would be moving with certain speed. Now, definitely because of collision, the combination of B and C will start moving with a different speed. From conservation of momentum, see board B is moving with some velocity, say V. So m times of V is the momentum carried by B, and C was at rest. So now together with B and C, they are moving with some new speed, right? That new speed, let me call it as V dash, or yeah, V dash. So we'll call V dash being equal to V by 2. So this is the speed with which our BC combination is moving. And A, since it is not having any impulse on it because of this collision, so it will be continuing its motion with V speed only. Okay, so this would be the condition at exactly t equals 0. Now after some time, what will happen? We'll check. Now if you observe B and C are here, they are moving with V by 2 speed, and let's say A is at, at some position with respect to C, so it has already covered a distance. Let's say this distance, let us name it as some x amount of distance. This x is a distance relative to BC system. So x becomes 0 at t equals 0. After some time, when A gets completely getting on top of C, so x becomes equal to L, right? So this is our initial way of describing x. So x is distance relative to the BC, B and C combination. Okay. Now this A is moving with some new speed. That new speed, let me call it as some u. Okay, u is the speed with which a is moving at an instant when we consider that instant as t. T is the time instant at which it is moving. Now, after some time, so when A stops relatively moving with respect to this combination, let's say B is here, C is here, so A would be here on top of C, and this entire system would be moving now with some collective speed. So since you know that if there is no relative motion between A and C, then this overall together, this entire system will be moving with 2v by 3 because of conservation of momentum, this entire thing, because 2mv being equal to 3m times of the new, that final speed. Let's say the final speed would be 2v by 3. Okay, this is our description. Let's say this configuration is achieved at t equals capital T. Just A stops moving relative to C, and this configuration is achieved when t is equal to capital T. This is our consideration. Now, if you look at the intermediate stage when x is described as some value here, so definitely there will be a frictional force between A and C, right? Because of that frictional force relative to BC system, A is moving rightwards with an speed rightwards, right? So there will be a frictional force acting on the so-called block A in the leftward direction, and this frictional force would be in its kinetic and kinetic friction format, and on BC the frictional force would be right hand side. This force is actually acting on C, but B is attached to C, so even B will follow along with it. Okay, so I'll be just using that frictional value as just force F. Okay, so this force F, if we think about free body diagrams, free body diagram of let's begin with say BC combination. For BC combination, we have force acting rightwards with the value of frictional force, which is equal to, I'll be using mu mg, right? So mu, the portion of mass which is on top of C would be some x distance. So lambda times of x is the mass present on the top of C. So mu mg we have. So I'm using lambda, which is mass per unit length, since they are uniform is what we are assuming here. So mass per unit length is lambda. Okay, so this is a frictional force, and this frictional force is acting rightwards on our mass 2m bc, and as a consequence, it will have an acceleration rightwards. Okay, so this acceleration rightwards, let me call it as a. Then the acceleration a can be evaluated. The value of acceleration a would be, um, can we say that mu lambda xg is the force acting, and the total mass would be 2 times of m, which can be written as lambda times of L. So the overall acceleration from ground frame is mu xg by 2 times of L. Mu xg times 2 times of L. So this is the acceleration of BC combination with respect to ground frame. Okay. Now we will think about uh, this free body diagram of our block A with respect to BC combination. BC combination. Okay. With respect to BC combination, let me use small letters only. BC combination. Okay. So BC combination here, with respect to BC combination frame, if we observe free body diagram, we have frictional force on our mass, which is acting leftwards. As we have already discussed, the frictional force is acting leftwards, and since our BC combination frame is accelerating rightwards, there will be a pseudo force which is acting leftwards, which is mass times the acceleration a. But we know that with respect to BC combination frame, the so-called block A is moving right side with a velocity which is given as u at some time t, and we have the acceleration of this particular block, which with respect to BC combination frame, right? Let me name that acceleration as some a dash. Okay, So A dash would be the acceleration in that way. Now we can find that frictional force plus mass times the acceleration should be equal to mass times A dash. So from Newton's laws. So let's solve for this. So we'll have mu lambda xg, this is frictional force, plus lambda L times of acceleration, which we got here already. So mu xg by 2L, which is equal to lambda times of L times of A dash. So we have acceleration A dash being equal to 3 by 2 times of mu xg by L. Okay, so this is what we will get, which is the acceleration of block A with respect to BC frame. Okay, so I think up to this point that there is no confusions, I guess. So if there is some confusions, you can put that in the comment section. So I will try to reply it quickly. Okay, so going further. Now, as you know that these are the accelerations, our intention is to get the displacement of A with respect to ground frame when A stops relatively moving with respect to BC, right? So we need to take this particular information and bring that information to the displacements, right? So we'll try to do that by using a little bit of calculus. So since acceleration A dash is given as 3 by 2, now we have found 3 by 2 mu x g mu xg by L. This is what we have. So we are using the variable small u for our description about speed as a function of time, right? So we can definitely write this a dash value as u du by dx, u du by dx. And if you're writing like this, as we know that this is magnitude wise, it's fine, but direction wise, if you see that acceleration would be negative of this, okay, negative of or 3 by 2 mu g by L x, right? So acceleration displacement or movement is in the opposite sense. Now, anyways, u du being equal to 3 by 2 mu g by L times of x times of dx. Now, suppose if dx is positive, and we know that speed acceleration is in this way, right? So speed is going to reduce. So we'll have du being negative for positive dx, correct? Now, with this, let's integrate and get a relation. We already have this information. When x is 0, the value of u is given to be v by 2. When x becomes equal to L, the speed of u becomes 0. This is relative speed with respect to BC combination, and x is the distance with respect to BC frame only. Okay. Now, using this information, just integration, you will have this u squared by 2, 0 to v by 2, which is equal to 3 mu g by 2L, and x squared by 2, 0 to L. And with simplification, you will get the value of mu from this. Value of mu can be arrived or simplified as v squared by 6gl. Just simplification, substitute the value of upper limit, lower limit, simplify, you will get the value of mu. Now we have the value of mu, but suppose if you want to have the speed as a function of x, then we already have this mu value. Suppose if you wanted this speed as a function of x, instead of limiting this values in this way, we can even change from v by 2 to this being equal to some u value, and this being equal to some x value. This also we can do. But I think we have a better way to simplify this acceleration stuff. So a dash being equal to 3 by 2 times of mu x g by L, right? So here in its magnitude form, this is fine. But in by considering the direction, we can say considering direction we can say that A dash being equal to minus 3 by 2 mu x g by L. So already we have the value of mu, right? So plugging that value, v squared by 6gl times mu squared by 6gl times of x. So we'll have the value of acceleration A dash being equal to negative of, so v squared by 4 times of L squared times x. By just looking at this one, I think you can get the pattern here. We can relate this mathematical function in this way because we are already familiar with this kind of function, like how to find the solution for x. This is something which we have encountered in SHM and etc. So here we can use the value of omega being v by 12. So there is a regular way of integration also gives the same answer. Whatever we do from this assumption of the function as a solution and deriving results will give you the same answer. I'm just using this so that it saves time. Okay. So x equals a sine of omega t plus phi would be our general solution for this. Okay. Now here x is the distance with respect to BC combination frame and a is some constant. It should have the dimensions of length sine of omega t plus phi because it satisfies this particular acceleration and displacement relationship. Okay. Now to fix these, in order to fix the values of this, let's take some initial condition, boundary conditions. Okay. So we already have this at t equals 0, x equals 0. Since at t equals 0, x equals 0, then phi should be, which implies phi should be equal to 0. We have x being equal to a sine of omega t. This is our condition now. Now let's differentiate this. So dx by dt, which we were calling it as u, which is equal to a omega cos of omega t. And we also have this information at t equals 0, at t equals 0, we have the value of u being equal to v by 2. Okay. So just plugging that value, v by 2 being equal to a, omega value is v by 2l. We already have this. And cos 0, 1. So we have the value of a being equal to L. So the function that we are looking for, x as a function of time, can be obtained like L into sine of v by 2L times of t. That's our function. Now, once if we have this, we can easily find out after what time this A stops moving relative to BC combination. So for that, let me take this x equals L times of sine of Vt by 2L, right? So Vt by 2L at x equals L, meaning when relative motion stops, right? X would be L, right? Then T becomes capital T, let's say. So we have sine of Vt capital T by 2L. So with that, we can just say sine inverse of 1 being pi by 2 Vt by 2L. So T equals, we can write pi L by V. This is a time after which it's going to stop moving relative to the platform or BC combination. So this we have. Now, already we know that with what speed it is going to move as a function of time, dx by dt, this we already have, which is a omega, which is L omega v by 2L, a omega cos omega t, right? Cos of omega t, where omega is like v by 2L times of t. This is what we have. Or u as a function of time, if we see, that is v by 2, which is cos of Vt by 2L. Okay. Now the plan is we need displacement of A with respect to ground frame, But what is happening is the A is moving relative to BC combination. BC combination itself is moving, and A is moving with respect to BC combination. And as you are aware of this, the displacement of A with respect to ground frame is displacement of A with respect to BC combination plus displacement of BC combination with respect to ground frame. So we already know this BC displacement of A with respect to BC combination we know as L, but displacement of BC combination, this thing which we are not aware, let me call this as some X dash or something. Yeah, this we don't know. And this is our question. We are supposed to find this one, correct? So how do we even get this X dash? We'll think of conservation of momentum. Okay, so conservation of momentum, using the logic of conservation of momentum here. Imagine that suppose at some instant of time, if our A is moving with u speed and B here and C here are moving with some speed, right? So they will be moving at certain speed. So definitely, if we consider the idea of conservation of momentum, let me use the symbol for this one as V double dash, let's say, for B and C combination. Okay. Now B and C are together moving with V double dash, and U is the speed with which A is moving relative to BC frame. Using conservation of momentum, now we can say this uh, overall momentum, initial momentum of the system is 2m times of V. This was the initial momentum. That should be equal to mass m, which is mass of A, times u, and this is with respect to BC frame, and we have to bring that to ground frame, so V double dash plus, and B and C, they are moving, their mass is 2m and they are moving with V double dash speed. Okay, so initially this m was at rest, no, so we don't have to worry about it. So this is what we have. So 2v is equal to u times, and we'll have V double dash 3 V double dash. Okay, this is what we have, and V double dash turns out to be 2V by 3 minus of U by 3. So this is the logic that we have now. So what is this V double dash? V double dash is the speed with which this BC combination is moving, which is D times uh, position of B with respect to C changing with uh, position of BC combination with respect to ground changing with time, right? So that X dash what we were saying, right? That is nothing but position of BC combination with respect to ground frame. This is what we were thinking about. Okay. Now, if this is the case, then displacement of BC combination with respect to ground frame can be written as 2V by 3 dt, and u value already we have, which is V by 2 cos of Vt by 2L. So we have V by 6 and cos of Vt by 2L, and there is dt here. There is dt here. Okay. Now let's integrate this, and we have to integrate this up to what point? Up to the point where it stops, right? So t equals 0 to capital T, 0 to capital T, and here 0 to some displacement will cover, and that is the displacement which we are interested in. Okay, so this is our required displacement of BC combination. Okay, let's do that integration. So we'll end up getting displacement of BC combination with respect to ground frame being equal to 2 pi, okay, say just 2v by 3t, 2v by 3 times t, minus we have here v by 6, v by 6, and let's integrate that cos of Vt by 12. Cos of Vt by 12 will get sine of Vt by 12, and you have this limits 0 to t, and the value of coefficient of t. Just divide that. So you can simplify this. XBC with respect to ground frame turns out to be 2 by 3. The value of Vt, because you have T equals pi L by V. Pi L by V. So Vt is nothing but pi L. So 2 by 3 pi L minus of, we have L by 3 here. And when you substitute this uh, value of capital T in this, you'll end up getting sine of 90. The other one anyways will go to 0. Okay. So this becomes 2 pi minus of 1 times of L by 3. This is displacement of B, C combination with respect to ground frame. But we need displacement of A with respect to ground frame, which is displacement of A with respect to BC and displacement of BC, right? So displacement of A with respect to BC is L plus 2 pi minus 1 times of L by 3. So we can simplify this and we will get the value as just 2 pi plus 2 times of L by 3, which is displacement of A with respect to ground frame. So in the given question, they have said that take the value of pi equals, take the value of pi being equal to 22 by 7, right? So just substitute here, we'll end up getting 58 by 21 L. That's the displacement of block A with respect to ground frame. So I hope you understood this particular problem, and the value of alpha in our question is 8. So dear students, thanks for watching and all the best for your advanced examination. Thank you.